BGP, the simple metric. Well, that title is totally tongue-in-cheek because there's nothing simple about the BGP metric at all. I would probably say half the complexity of BGP comes in this idea of the metric, and I put that in quotes simply because BGP doesn't really have one. So the goal of this nugget is simple. It's to walk through and understand together how BGP finds the best routes of the internet to add to the routing table. Let's get started. Here are our standard do I know this already questions, so if you know them, you can move right along. Bam! Right from the onset, I hit you with this monster slide of the BGP path selection process. In simple terms, this is how BGP figures out the best routes to put in its routing table. It's going to be what we break down here. So to start off that discussion, let me ask you a question. Is there redundant connectivity on the internet? Ping! Yes. Everywhere, right? If you've ever seen a network diagram of the internet, ever seen one of these where they show it looks like this. It's actually it's usually blue. They have blue on the outside, and it's kind of like a gradient, kind of fading into. And this is my pathetic interpretation of this, fading into a red in the middle, and they have a key on the side saying, up at the top, this blue represents 10 to 50 connections, and all the way down to the red being like 1,000 connections coming out of certain sites and things like that. So essentially it shows all the service providers banded together to build this monster redundant network that we call the internet. So this picture right here is just one example of that. We have ISP1 and ISP2 and our ISP sitting right here. We're ISP3, let's just say. ISP1 and ISP2 are connected through their variety of ISPs that they're uplinked to, and those varieties are linked over here. So this big cloud just represents the whole blob of ISPs all around the world that eventually bring these ISPs together, right? And into us. So somewhere out there, let's just say in Istanbul, I don't even know where that is, it just came to my head, there is a network 55.1.6.0 somewhere out here in the great abyss we call the internet, and it ends up getting advertised in, and we hear about it through a BGP relationship with ISP2, and we hear about that same route through ISP1. So the question is, which is it going to choose, and why? Why would this route from ISP1 maybe be more preferred than this route? Does it look at bandwidth? I mean, when you think about metric, right? Think about the word metric. We know it typically in an interior gateway protocol way. So let me ask you this. What's the metric of RIP? Hop count, right? How many hops away? Okay, that's how RIP finds the best way. What's the metric of OSPF? Cost. It's 100 divided by bandwidth in megabits per second. What's the metric of, okay, more complex, what's the metric of EIGRP? And you could say hybrid because it uses bandwidth, delay, reliability, load, MTU if you factor those things in. So it makes EIGRP feel a little more complex. But when I say what's the metric of BGP, that's it. I mean, I guess you could call it hybrid, but it's more of a decision tree. Like if you've ever seen, those flow diagrams where it's like, well, if this, then this, if that, then that. It's kind of those flows. So this is an ordered list, and I would recommend memorizing. Yes, memorizing up to right here. Let me give you an example of actually one of the most powerful metrics that is out there is the shortest autonomous system path. Matter of fact, this autonomous system path is the first thing that we know as an attribute. It's the first time I'm using that phrase. What is an attribute? Well, every single one of these routes floating around the internet has kind of like a baseball trading card attached to it. I recently was cleaning out my house because we have 5 children in a 1,700 square foot house. We smushed them into rooms, and we're like, what can we get rid of? So I pull out my old baseball you know what I mean, under the bed. I'm like, look, it's my baseball card collection, and my wife goes, it's gone. I was like, oh man. But you flip those baseball cards on the back and you see all the stats of the player, how, what their batting average is and all this kind of stuff, right? Well, each one of these routes roaming around the internet have their own little baseball card attached to it. It's all this stuff. They're known as their attributes. And based on their attributes, you can say, I like this route more than the other. You want to know one of the most powerful attributes that exists out there? The autonomous system path. Every single time a route goes through an autonomous system, let's just say a service provider, which is typically one autonomous system. They could be more than one. It gets a little passport stamp on its baseball trading card, on its stats, saying you've been through this autonomous system. So let's just say that we have the network, we have the sacred network 1.1.1.0/24, right? Oh, we've got it. And we advertise that out. Well, when we send it out, we will actually put a little stamp on that. Let's just say our ISP is Autonomous System 5000, right? We will put a little stamp on the back of this route. Let's just say it's 1.1.1.0 on the back of his trading card saying it has been an Autonomous System 5000. That then goes out to the rest of the world, and these guys, let's say this guy's 6,000 and this guy's 7,000 on the Autonomous System. As it goes through their network, they will put a stamp on there to where now 1.1.1.0 has the stamp 5,000, right? That's us. Then it went through 6,000, which is ISP2, and then, as it goes throughout the rest of the world, it gets all these little passport stamps, and that's one of the most powerful metrics because, or I should say attributes, because out here in the cloud world of Istanbul, they receive the 1.1.1 route or 1.1.0 route from their uplink carriers. They're going to say who has the shortest AS path on their baseball trading card. Meaning, I want to choose the one who has the least amount of autonomous systems attached to it. So, one of the most powerful attributes in our list is actually a hop count. How many systems have you gone through? It's very similar to RIP when you really break it down. But can I add one more thing to this? This attribute is BGP's only loop prevention mechanism. You ever thought about this? We've got all these routes floating around the world, right? 1110, we just launched it out to 2 different ISPs, advertised it to them, right? They're going to send it to their friends and their friends and their friends. So our little 1.1.1.0 route becomes pretty popular all around the world. Everybody gets it, and before long, ISP2 gets it from, through this big chain of ISP1, and ISP2, sends it out here, and ISP1 gets it, and we actually get our own route back and things like that. Well, what's to prevent this route loop madness from happening? Well, it's very simple. If an ISP sees its autonomous system in the AS path, it drops it. Meaning, if it sees the 1.1.1.0 route come in from some other ISP, from some neighbor, and it says, hey, I have Autonomous System 6000 in this list. Maybe it's gone through 50 other ISPs between here and there, but if ISP2 sees 6000 in the list, it's like, oh, looped route, drop it. So truth is, there are billions of looped networks going through the internet as we speak. It's just as soon as they reach the autonomous system where it would cause a problem, if it were to accept it, it gets dropped because of the autonomous system path, right? Very, very key attribute. The reason I focus so much, just from the onset, as we're even discussing this on this one, you might say, well, why are you saying that's so powerful? It's number 4 in the list. It is, but most of the time, these ones, unless you and I, as administrators, get involved and set them, are going to be set at whatever the default is, which is most of the time 0 or some other default value. So essentially, if we do nothing, if we turn on BGP and let it start forming neighbor relationships, it's going to say, well, that's tied. Well, that's tied. Locally originated, of course, a router is going to prefer routes that it puts into the system over routes that it receives from everybody else. So if for instance, I originate 1110 and someone else says, hey, I have 1110, I mean, come on. You're like, it's in my back door. I'm not believing you, right? So these are all things that just happen by default. So this one, out of the box, is one of the most powerful metrics that we have, or attributes that we have, attached to that baseball trading card. One of my goals for this nugget is to get you familiar with these attributes. Familiar in such a way that where you're like, oh, okay, I kind of get what they are. I see the key elements. But know that there is an entire BGP series where I virtually dedicate a nugget to each one of these attributes. So if you do want to just dive deep into them, I suggest head over to that series and break it down. We'll also dive deeper as we go further in this series as well. So first off, what am I saying on the title of the slide? Well-known attributes. Well, that is RFC language. When the powers that be invented BGP, they said in order to be industry standard, industry compliant, you need to support these attributes on your routes with BGP. So essentially, if a router doesn't support these, it's a proprietary flavor of BGP, and I will tell you, everybody supports these. Now, in the well-known attribute world, there are actually 2 different flavors of those. There's well-known mandatory attributes, and there is well-known discretionary attributes. So let's put the pieces together. Well-known means RFC standard, right? Everybody has to support them. Mandatory means they have to be in the update. You cannot send a BGP update and let somebody know about a route, like I can't advertise that route without well-known mandatory attributes being included on that route's baseball card, right? Well-known discretionary is just as the name implies, it is industry standard. Everybody supports them. However, it's up to you if you want to include them. You don't have to, but you can if you want to, right? So that's the two different flavors. You'll want to know this. What are the well-known mandatory attributes? They are origin, as in where did this route come from? AS path, as in what autonomous systems had it gone through. You remember from the last slide that obviously if that's BGP's loop prevention mechanism, it better be there. And then last is the next hop, meaning how do I get to this route? What is the next hop I go to get there? That's it. That is all the well-known mandatory attributes that have to be there. So when ISP1 advertises the 150.1.1.0 network to us at our ISP, it will have an origin field on there where it will tell us one of three things. This route came from I. You'll see a little I on there, which means it came from an interior gateway protocol or somebody's internal system, right? It will have an E, an E on there. I can't even say that without squeaking. An E on there, which means it came from EGP, EGP, the exterior gateway protocol, which is very confusing to people because they go, oh, well, that means BGP, right? No, actually doesn't. BGP had a predecessor. What's in Star Wars, what is it, the Sith Lord? What is Yoda? He's the Jedi Master, right? So EGP was BGP's Jedi Master, right? This came along long before BGP ever existed, but BGP became BGP just killed EGP. It's gone, right? Nobody uses that anymore. BGP became the standard. So this E on the origin code is essentially for a defunct protocol. So if you ever are looking at the origin and you see an E in there, it's a lie. There is no EGP anymore. And that's the confusing thing about it is EGP is both the name of this old Jedi Master protocol, right, that nobody uses anymore, but it's also a category of protocols. There is the exterior gateway protocol, now dead, killed by BGP. There is a category of protocols called exterior gateway protocols, of which BGP belongs to, right? And it's actually the only one that really holds any weight in the world today. So this E is a lie. Now, you might wonder, well, it's a lie. So can people lie? Yep, they can. You'll find when you get to BGP that you can actually adjust these attributes all over the place. There's one more origin that I'm going to throw out there, and it is a question mark, meaning I have no idea where this route came from. Seriously, this is RFC, industry standard language. So when you send this route, the ISP can say, hey, here's a route, and don't know where it came from, but hey, it looks good to me. It's out on the internet somewhere. Now you and I and they and everybody out there can adjust these origins. You can actually run them through filters, use route maps. BGP is almost like, and I hesitate to say this because I'm not really much of one, but it is almost like coding. Right, like programming, where you say, well, I want to set this and modify this, and then create these if-then statements. If this happens, then this. If this and this. Okay, so hang on one second. I'm taking you back here to our path selection process. Take a look at number 5, this origin deal. Where does the origin come in? Well, notice it. There we go. I come down here to number 5. So it says if this is tied, if this is tied, if this is tied, if this is tied, like you have two routes that have the same length of AS path, then it comes down to say, well, let's prefer the lowest origin type. Meaning, if this one has an origin of it came from internal, and this one has an origin of the ISP saying I have no idea where this route came from, then this one is going to be preferred, and that ends up in this routing table as the best route. So you see, can you see how these attributes start influencing these decisions? But it seems kind of random because the ISPs can tune this. You know, they could receive it and it could say, well, I have the origin of I, and they could run it through their filters and they could say, well, actually, I want to change that to say I have an origin of question mark. So it's not like you can just do a show IP BGP, which shows you the entire BGP table of what it knows about, and look at these origins and be like, oh, well, I can tell this one came from it. I mean, how on earth do you get an origin of question mark? I don't know where this came from. Does that not compute in anyone else's mind? Like what? Did it just fall into the internet routing table? It didn't. I mean, these attributes are really just they're like crayons, right? This is a blue crayon, this is a red crayon, this is a yellow crayon. Which crayon do you like best? I like blue. Well, they like yellow. That's okay, whatever. Remember the golden rule of BGP from the last nugget. You can never tell somebody else how to route their traffic. So all of us in the service router world make our own decisions on what metrics we prefer. Isn't this whimsical world of BGP kind of fun? I mean, it really is a world of create your own rules. So origin, we talked about that right now. Autonomous system path, we've talked a lot about already, so I won't spend much time on it other than to illustrate one more time that this is the loop prevention mechanism of BGP. Let's say that ISP2 actually originated 150.1.1.0, right? They are the ones that own that, and they use that for their customers and everything else coming out of that ISP, right? They advertise that to us. We're autonomous system. Let's just say we're 50, right? So we put our stamp on the back of that baseball trading card of 150.1.1.0. It now has it. Let's just say it originated in 25. We stamp 50 onto that, and we send it right along to ISP1, who is let's just say 30. So they put their stamp on it, right? So then they go through the big cloud we call the internet. It eventually makes its way back here. This guy receives the route passing through our system, through ISP, through all these other ISPs, and receives it, coming in over here, and looks and goes, aha, my AS number is in this AS path already, so I will not accept that route coming in this direction, right? Because that's a loop. So that's one of the key goals of AS path, as well as being one of the strongest metrics available for it. So, for instance, by time 150.1.1.0 gets to us from ISP2, it only has one AS path in its passport list, 25, right? Because ISP2 originated this, whereas ISP1 would hand it to us. We know 25 will be the first one because it originated from there, but it would have gotten to ISP1 through this series of other ISPs, so it would be 25, 59, 152, da, 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 da. So it comes to us. AS path wins. It goes, oh, well, this is way shorter. I'm going to go this route. This is my preferred route that goes in my routing table. You see how that works, yeah? Next hop. Now, this is an attribute, but not really used to break ties by any means. It is what it sounds like it is. Next hop attribute is sent to say, this is how you get there. So I'm advertising 150.1.1.0 to you. My IP address here is 1.5.9.22. So that will be the next hop attribute that you use. Now, when you get more into BGP, which we will, you will find that next hop attribute can be a booger. Seriously, when you start getting into internal BGP, you find out that one of the rules of iBGP is that it never changes attributes. So for instance, as you go from, let's say this is your router that connects to outside ISPs, well, got other routers in here, your core devices, all this kind of stuff. It's going to hand these routes and hand these routes and hand these routes down the way. Well, the next hop attribute is 1.5.9.22 comes in right here. iBGP doesn't change it, so as it passes that route to this guy, it says, hey, I know about 150.1.1.0, and the next hop is 1.5.9.22. So this guy's like, oh, so it's not you, it's him? So it actually, unless you do some tweaking of your routing table or change the rules of BGP, which is actually not recommended. Cisco says you should never change the rules and adjust the next hop, although we'll let you do it if you want to. Things can start breaking in your network. So more on that later on. Now, last two, I just want to hit these. Actually, let's just do this one, atomic aggregate. Aggregate is summarization, right? When you summarize a group of routes, let's just say you've got 150.1.1, 1.2, 1.3, and you sum them all up and say, I've got 150 dot everything, /8 or, whoa, got crazy there. 150, 0.0/8 as my summary. That you create a summary route and you become the aggregator. The atomic aggregate is essentially identifying who did that, who summed all this stuff up. So it's mandatory, yeah, it's in there, but it's not really used for route selection or anything like that. This one is local. I want to talk the last two attributes. I feel like I'm like trying to sell you something. I just got one more thing to say, and then you buy now, right? So local preference and weight. two very powerful attributes that you can use. First off, weight. Cisco proprietary attribute. But that's okay because it is an attribute that is never advertised to another router. Here's all the way it is it is a very simple way for us to identify on our router which one we prefer, right? Come back to this list with me. Hang on, shoop, right about there. You saw the number one most powerful thing. Of course, Cisco would make theirs, right? Proprietary attribute. Most powerful way of picking a route is the one with the largest weight. Okay, so coming back here, what does that mean? It means that you or I get on this router and we see these routes coming in and we say, you know what? I like that one. ISP, even though maybe ISP2 would be normally preferred through the AS path or origin or whatever, further down the chain method, I want to say that this guy has more weight. So with weight, that's a mental note for you, higher is better. And I can go on to that router. Let's just say this is router 1, and I can say, as you receive from ISP1 this route, and we do that through something called a route map. Route maps are actually how we set most attributes in BGP. I can say, okay, as this route comes in, I want you to set it with a weight of 500. This guy comes in and let's just say it has a weight of 100, right, or something like that, a default weight or some pre route map that we've done for somebody else. Anyway, so we say this has a weight of 500. It's like I will not look any further. This is bing 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 the preferred route for 150.1.1.0. So we have total control to overrule everything with the weight. The big difference between the weight and the local preference is who do you tell? The weight, because it's Cisco proprietary, never leaves this router. So what does that mean? Let's say I've got a very simple topology up here. It's actually not normal to be that simple as an ISP. We normally have at least two different routers that are connecting to our other carriers, right? So let's just say we've got ISP1 up here, ISP2, very, very similar kind of thing. And we've got redundant routers, right? Chunk, 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 chunk. Chunk, 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 chunk. All of this interconnected mess. Router 1 and router 2. So I receive as router 1 this 150.111 route from ISP2, and I receive the same route from ISP1. If I set the weight like I was just talking about, then it says, okay, I prefer this way, but I'm never going to tell router 2 about that. Right? Router 2 just goes along his merry way, making whatever his decision he wants to on which ISP he wants to use for 150.110. Right? That's the difference with local preference. Local preference, hang on, it's the next most powerful one in this list. Notice weight is number 1. Local preference is number 2 in this list, is where we come in. It does exactly the same thing. I say I want the weight of 150.1.1.0 coming in from ISP1. Did I say weight? I want the local preference of 150.1.1.0 to be 1,000, right? A very, very strong local preference. Now, if this were weight, router 1 would say, okay, I prefer this way, but I'm never going to tell router 2 why I prefer that way. I'm just going to say, hey, this is my preferred route. That's about all you need to know. But with local preference, I will say, I prefer this way because it's a much higher weight than whatever was set on this route. But then I'm going to advertise that to router 2 and say, hey, router 2, I've got 150.1.1.0 with a local preference of 1,000. Now, unless someone other than us, or maybe us, has gone on router 2 and said, well, it's going to be 2,000 to go this way, done something goofy like overruled that, well, router 2 is going to say, well, I'm not going to use either one of these ISPs. I'm going to send it on this little back network that I have here over to router 1 because he's got a great route to 150.1.1.0. He's got 1,000 as a local preference attribute. Essentially, we get 3 baseball trading cards for 150.1.1.0, and router 1 just says, I've got the one in mint condition because I've got 1,000 local preference, and he tells all of his internal friends about that. What word did I add there? Internal friends. That'd be 2 words. Internal friends. Internal local friends, right? Local preference is not sent outside of our system. It's only sent within our system. Once again, the golden rule of BGP, we can't tell somebody else how they should route their traffic. We can suggest it, but local preference is actually not the way to do it. Local preference stays local, so it goes between your autonomous system routers, but is stripped off as soon as it goes to somebody else. Oh, that was some good stuff. That was fast and furious and dense, but just so rich with information. That is the simple metric of BGP. You now have seen how BGP finds the best way around the network. It goes through that gamut, that list. Now, granted, we did not go through that list in its entirety and say this is this and this and this, because frankly, it doesn't matter. We went through the key attributes, which are those first four. Where are we? Right here, right? These first four, right here, actually first five, right? We added those in. These are the key attributes because that is what makes your decision on 99% of the routes that are coming into your system. And those are the big ones you want to know when you're first getting into BGP. I hope this has been informative for you, and I'd like to thank you for viewing.